All right, so let's do this the same way that we did them yesterday. Okay, and then hopefully maybe we can make a quick recognition of an alternative approach that might make things easier. Okay, the way we did yesterday should not be all that difficult in this problem, though. So remember yesterday what we did? If we had logs on both sides, what did we try to do? We try to simplify them, but in order to do that, they have to be. That's what we're going to do here. We had to have all the logs on one side. Remember that? Okay? Because if I'm going to use, so what we're going to try to do is use these rules. If I have the log of A plus log of M, that's going to be the log of AM, right? If I have the log of A minus the log of M, that's going to turn into log of A over M. We're trying to get one of these things to happen, so we need either that or that. So that means we need both logs on the same side, right? So we're going to move this log 19 to the other side. Okay, so I'm subtract log 19 here, subtract log 19 here. Now, when we do that, like I don't know what log 2x plus 5 is, I don't know what log 19 is, so I can't make those one log. We have to rewrite this as log of 2x plus 5 minus log of 19 is equal to, now, if I subtracted this whole side, what is left over there? 0. Yes, and this one would be 10, yes. So what does subtraction turn into if I've got the logs on the same side here? Division. So I'm going to rewrite this as log of 2x plus 5. Can we slow down? Over 19. Thanks, appreciate it. So is everybody okay going from that to that? Okay, going from what we started with to this. Okay. Now, yesterday we said once we get one log written, okay, we can use the rule that says, it's the definition of a logarithm, that says that if and only if b to the y equals x. So we now have that side written here. Let's do this to it. So you take your 10, write that down. What am I going to raise that to? I'm going to raise it to the 0. And what's that going to come back and give me? 2x plus 5 over 19. Okay. What is 10 to the 0 the same as? 1. Okay. Now, how do I get rid of that 19 on the bottom here? Multiply by 19 here, multiply by 19 there. So we get 19 equals 2x plus 5, right? Can you guys solve that? So subtract 5 from both sides. Gives me 14 equals 2x. Divide by 2, I get 7. X is 7. Okay. Now, would you guys agree that all that stuff right there was maybe a tedious process? It involved a lot of knowledge about other like the logarithmic procedure going from a logarithm to an exponent, that kind of thing, right? Look at the original problem. Okay? How can I go from this original problem to this right here? Yes, everybody see that? This here ends up being that right there, right? The 2x plus 5. And that there becomes the 19. Okay? That is called, and that the reason that works is because of what we just went through. Okay? But that is referred to as a, what we call a 1-to-1 correspondence. Like corresponding angles talks about like their locations. So, right. But the word correspondence is being used in a different way here, different manner than what it is there. But a 1-to-1 correspondence, what it means, you've seen this before. If I want to make this fraction, on the left the same as the fraction on the right, what has to be x? X has to be 2. That's 1-to-1. Because the denominators are the same, the numerators have to be identical. And that's how we get x to be 2, right? So if I had something like this, if I had like x plus 3 over 5 equals 2x over 5, because the denominators are the same, then I can set the equal, or the numerators equal each other, right? Those are 1-to-1 correspondences that you've seen in work with fractions. The same thing happens with logarithms. If I have the logarithm of, I'm just going to say, we'll call it f of x right now. Actually, let's just do this. Let's call it u. Okay? And that is equal to the logarithm, I'm just going to say z, where u and z can be algebraic expressions. They can be 2x plus 5. They could be 19. They could be whatever we want them to be. Okay? But because this log has the same base as that log. Now, in this case, it's 10, but it can be anything. It doesn't matter what the bases are as long as they're the same. Does that make sense? Then what we do here is we can say we can make a 1-to-1 correspondence. The only way that the log of whatever this is equal to the log of whatever this is if u and z are the same. So you can make that jump straight to that. Maya? No. If the bases are different, there is it's called a change of base formula, and it gets very messy on, we're not going to do those. Okay? Now, this only works if you have one logarithm on each side. So if I said I had, let's go like log, we'll just make it easy here, log of x equals log of, let's actually make this log of x plus 4. And I have the log of 2 plus the log of x. I have log once on the left-hand side, but I got it twice on the right-hand side, right? You're going to have to go through some preliminary work to take these two, which are being stuck together with addition, and turn them into what? Yeah, I can merge those into multiplication now. And now what can I say about x plus 4 and 2x? They're equal. And now allow me to solve for x. X would be 4 in that case, right? Does this make sense? Okay. Does anybody have questions on this? What I'm going to do, I'm not going to give you a new assignment. You might have some questions in your homework that are over this, but we still have an assignment open, 7.6 day 2. Okay. Let's spend the remaining time working on that. Okay.